All right, welcome back, everybody. GE 101. This is going to be a fairly short lecture on graphics. I've been through all of your Project 1 submissions, and some of the graphics were, all over the place. That's okay. But I just want to dial that in a little bit more and make sure you understand that when I say we want engineering quality graphics, that has some meaning to it. So some of you are in GE 115, which is the AutoCAD class, and you're getting some graphics in there. And then some of you have had my other classes in which we've gone over orthographic projection and sketching kind of in more detail, but I'm going to kind of briefly do it here. So I'm going to minimize myself a little bit. All right. And here we go. Let me just remind you before I get started that we want to, in our projects, we want to try and run this loop as much as we can. So you should be in this area where you're generating ideas and brainstorming, those kind of things to document that information, please. All right, so let's talk about graphics. So this is a standard detail. This would be one object that we're trying to describe graphically, right? This doesn't show any dimensions, but typically the detail would show dimensions because its job, what we're trying to do is we're trying to provide shape description for the object, okay? But just the general layout of the drawing should include a title block. That's this information across the bottom. And in that title block should have things like scale. If it's a big object and you had to scale it down, how much did you have to scale it down to get it onto the piece of paper? So that can be 1 to 10, that can be 1 to 100, and you can also flip it and say it's 10 to 1, which means you enlarged it if it was a very small object. So typically there's 3 views, and those are what are called orthographic views. Front, top, and side are the primary orthographic views. And they are flat views of a 3-dimensional object. We want good line quality. What you're going to do for me as a homework assignment is some sketching, just pencil and paper, which I'll demonstrate. But we want as good and tight line quality as possible. We want the lines to connect nicely, not overrun or underrun or have gaps. There should be hidden lines for geometry that we cannot see. So hidden geometry. And then dimensions, like I said. So, all right, so here's an example of some graphics that have been submitted in the past, right? And you can see my comments. So these are students, actually not engineers, but which one do you want to be, right? So you can see that they maybe even used a straight edge down here in this graphics. It's super easy to pull a straight edge out and use that, and it gives you a much nicer quality. But let's talk about orthographic projection. So normally we're trying to document a 3-dimensional object, and we were doing it 2-dimensionally, so on a flat piece of paper. That's going to involve the front, the right side, top side, and maybe some other views, but you're looking at the object kind of flat on. So there's this thing called the glass box effect. And it's as if you put a glass box around the object, and then you literally unfold the glass box. Now, most of the time, front, top, and right side is all you're going to need, unless it's a really complicated object. And then you might have to add the left side or some kind of auxiliary view. Keep in mind that not all lines are true size and true shape when you do this, especially if you have a slope surface, right? In one view, you might see a true length, but in another view, like the right side view of this object in the middle, that foreshortened line is not true size and true shape. So when you dimension, you can only dimension to true size and true shape edges that you can nicely see. Okay, so you have to be very careful about that as to what's true size and true shape and what I can dimension to. Also, you cannot dimension to hidden lines, only to the visible lines or the visible edges of an object. So these are the visible lines and visible edges of an object. You can see the top view there. all of those lines in the top view, they're visible. We can see them. On the right side, all of the continuous lines are the visible lines, and the hidden lines are the dashed lines. So that's how we represent them. Then we go to dimensioning once we get the flat view. Now, I've just done example dimensions. Obviously, these are crazy because the 79s are not the same size, right? But I'm just showing you some basic dimensioning technique here. We want to cluster our dimensions. We want them nicely organized, close to the object, but off of the object. So close to the object, but off of the object as much as possible. There's always rules, and there's always situations where we need to break a rule, but this is the guideline that we want, right? Extension lines are these lines that extend away from the object. They should have a gap between the object. They can cross extension lines, but there should be a gap between the object and the extension line. The dimension line holds the arrow. So the dimension line holds the arrow and holds the dimension also. Those cannot cross. So we do not cross those. So kind of in the upper left corner, you can see extension lines crossing. That's okay. But nowhere else do you actually see any line crossing a dimension line. So just some basic rules that we want to follow. All right. And then there is a line type for everything. So there are ANSI standards that we follow. And these actually are some of the standards for continuous lines and hidden lines and section lines. I don't need you to know that, but I do need you to know that there are standards and styles for dimensioning. This is an assembled view. So there's all kinds of controls, so we all do the same kind of thing. This is a typical plan view. This is more on the civil engineering or construction side of the world. This is a typical detail, right? So the single view detail showing hidden lines and dimension lines. And trying not to break any rules, but you can see the 25 degrees right in the middle of the object actually is on the object, which does break a rule. So many standards and organizational techniques to creating these kind of graphics, okay? All right, organization is the key. Ability to read it is the key. Most of what you're gonna do for me is gonna be sketching, so I wanna talk about that in a little more detail. Sketching has a lot to do with proportions, some decent line quality. If you use your engineering grid paper, it's gonna really help you with your sketches. Starting and stopping points and arcs and circles. So I'm gonna show you a few things, just basic sketching technique to give you some strategies on how to make them a little bit better, right? All right, let's do a new share. I'll go to the visualizer. Hopefully it comes up. Let's see what's going on here. Unplug it and plug it back in. Sorry. I might have to pause the recording and get it going here. So hang on one second. All right, I finally got it to work. I don't know why it didn't work, but let me just talk about sketching real quick. Helpful to have green paper. That's what I have going. And basic technique is you want to choose your start and stop point. So if you have a scale set up, then you know, like this is 10, because I can see 5 is there. So this is 10 units. So if I know that it's like, 5 inches per unit, 10 times 5, 50 inches type of thing. But you want to choose a start and stop point, and then you want to do short strokes to make your line. So don't just put your pencil down and draw it, but make these short sweeping strokes and use your grid paper. Like here's my stop point, right? Use that. So then if you have an angled line, again, you want to start and stop point. Then you want to work it from one direction to the other, right? And kind of bring it together. That'll give you the best, straightest line, okay? So that's basic horizontal, vertical, and inline sketching. Give yourself a start point, a stop point, and then work it from one direction to the other and just try and keep it straight, right? And you'll get it. All right. Arcs and circles, box them in. So really lightly box in your circle. I think you can see that. And then choose your quadrants for your circle. Kind of just, pick them halfway, right? This is supposed to be a circle. So then you want to start tangent, right? So these want to be tangent and tangent and tangent and tangent. So they start really flat and then you just kind of, work them around and you can draw yourself a pretty good circle. Not going to be perfect. You are sketching, but it's going to be way better if you box it in. So box those in, right? And then same with arcs. You would just box in an arc like that, and then choose your quadrants. And then the hard part is starting at, kind of tangent, and then you can pull it out and you'll get some decent arcs and circles. Okay. You're going to do some sketching for me. You're going to do some front view, side view, and top view sketching. So let me stop this share and go back to, I know I get very big when we do that, don't I? Go back to a different share. All right, so what you're going to do for me is you have a little homework assignment, number 1 and number 8. Okay, and you're going to sketch for me with the straight edge or without. It's totally up to you. A pencil on clear paper, so like printer paper. If you don't have any of that, you can get some from me tomorrow during the lab. You can put your green paper behind it and you'll be able to see the grid come through. So then you're going to sketch a front, top, and side view of these objects, number 1 and number 8. A size paper, that's 8.5 by 11 normal pieces of paper. And then include a sketched up title block, a scale, and your name in there. So get all of that going. And what I want is I want you to use a grid size of 4 inches. So each grid, so if you look at number 1, you can see it's broke up into these grids. It looks like it's 1, 2, 3, 4, 5, 6, 7 grids wide in the front view. So that would be 7 times 4 for the size, 28 inches. So you'll have to think about doing some scaling to get it down. So 4 inches by 4 inches for each grid. Draw me a front, a top, and a side view for number 1 and number 8. Okay. All right. So there was one more here that I was going to show you. Just so you kind of understand this scaling. So I'm going to do a new share. I'm going to pop up. Yep, new share. We'll see if the visualizer works again. Yep. All right, so here is the one that you're given as an example in the PowerPoint. And if I said that it's 4 inches per grid, that means that for every grid, right, that's 4 inches, okay? Now, some of them will have half grid spacing, so just be careful to make sure this is full grid, that's full grid. So there's no half grid in this one, but go back and look at those more carefully and see maybe they have some half grid here and there. But that essentially would make, this would be 8 inches. This would be 1, 2, 3. So from here to here is 24 inches. So 4 inches per grid. All right, I think you got it. All right, that's it. There will be a guest speaker link that you need to watch. That'll come up today or Wednesday, maybe Wednesday. So, all right, take care, and I'll see you all in lab tomorrow or Tuesday, depending on the year and COVID and everything else. All right.